Okay, section 1.8 is on perimeter, circumference, and area. So hopefully you know all these formulas already, but we'll see. All right, so for a square, so each side of a square we mark as S for side. So sometimes I use a lowercase s, cursive s like this, because my s's look like 5s. So I'm going to do a fancy s. And so the perimeter then would be 4 of the s's, and the area would be, you guys remember? Side squared, exactly. Like length times width, right? Side times side. Do you guys all know what those are? S's, my little funny s's. All right, so a rectangle. So I could have length, width, base, height. Doesn't matter what you call it. So let's say we have length and width. Then its perimeter is going to be like length plus width plus length plus width. So the easiest way to write that is 2L plus 2W. And our area is going to be our length times our width. So a triangle, it just depends on what side you have. So you can have like side 1 plus side 2 plus side 3. Like if this whole thing was side 1, side 2, side 3, that would be the perimeter. So there's no fancy formula for that. But the area does have a fancy formula. So if you remember for the area, what is that, Cam?
Half the base times height.
Exactly. So our area is going to be 1/2 base times height. So basically, if I erase these s's and I talk about my base being the distance from here to here, and my height being the distance that's perpendicular to the base, so that's an important concept. It does have to be perpendicular. Okay, so everybody look up here. So I'm going to draw some things in. What if I extend it and I drew like a box around all of it? The area of this rectangle would be base times height, right? Do we see that? Well, why is the triangle half of it? Well, this part is half of this whole rectangle, and this part is half of this whole rectangle. So that's why it's 1/2 base times height. Okay, that's where that comes from. Okay, so then a circle. The perimeter, what do we usually call that? Yeah. So when we talk about a circle, we don't often say perimeter, we talk about the circumference. And it's going to be pi times diameter. Or sometimes you write it as 2 pi r. Okay, and for some reason everybody always gets these confused. So they always say, we're like, oh, 2 pi r versus pi r squared. I can't remember which one's which. So the area is going to be the one that's pi r squared. Exactly. So the way that I recommend that you guys talk about these is when you talk about like an area, like an area rug, if it's like 8 by 10, we would say, oh, it's like 80 square feet. That's what we would say. So the area one is the one that has a square on it. Okay, because we talk about square feet, square inches. Okay, so we're going to do some problems with these. So it says pi is the ratio of a circle's blank to its blank. Anybody know those blanks? So if I divide out something by something else, I get pi. Exactly. Circumference to its diameter. Good. So find the perimeter and area of a square with side length of 12 inches. So if we have a square, or 12.5, I guess, and it's 12.5 on each side, when I talk about the perimeter, it's going to be 4 of those 12.5s. So I always try to do things like without a calculator if possible. So when I'm multiplying anything by 4, what I'll do a lot of times is I'll double it and double it again. So if I have 12.5 times 2, I get 25, and then times 2 again, I get 50. So that's how we would do 12.5 times 4, so we get 50. And our perimeter then would be in still inches. So imagine I'm taking like a measuring tape around, right? It's still just a length, it's still inches around. But if I talk about the area, it's going to be 12.5 times 12.5. And so what will its units be in the end? So it's going to be in our inches squared, right? So I have 156.25 square inches. So I don't know if you guys know, like, You should have probably talked about this in elementary school, but sometimes people forget all these concepts you learn in elementary school. So imagine I have like a square that's 3 inches by 3 inches. Okay. Each of the little squares is 1 square inch. It's like an inch by inch on each side, right? So when we're talking about an area, we're saying how many of those little squares can I fit inside the whole shape? So if you count how many there are, do you guys see how there's 9 of those? So there's 9 of the square inches. Does that make sense? Okay, so number 2. So it says find the area and circumference of a circle with diameter of 10 centimeters. So if we have a circle and going all the way across is the diameter, so that distance is going to be 10. Okay. So a lot of times I'll have you write everything very precisely. So sometimes I'll say as an exact answer. So if I talk about the area, it's going to be pi times r squared. So in this case, it's going to be pi times our radius is 5 squared. So our exact answer would be 25 pi. Okay? But notice I said use the pi button to round to 3 decimal places. Okay, we're no longer using 3.14, so we're not in elementary school anymore. We know that pi goes on forever. It never repeats, right? We know that about pi. So we use the pi button on your calculator. So everybody get your calculator out and look for pi. Okay, and this is an approximation because we're going to round to 3 decimal places, so we're going to cut it off. So it's going to be 78.5398. So I'm going to say 540 like that. So it's 78.5398. So I'm rounding to the 3rd decimal, so that's why I rounded up to 40. Does that make sense? Yeah.
And so when you know that there are more decimals, do you always use the approximate sign?
I usually use the approximately sign. Yeah, if you see that your calculator goes on forever and it's like, oh wait, there's more decimals behind that, I would use that approximately sign. Okay, so the one that's circled is what we call the exact answer. It has pi in it. Pi's a number. That's okay. And then the other one is the approximation. And this would be in centimeters squared because it's an area. And then our circumference is pi times diameter, or 2 pi r if you want. So it's going to be 10 pi, so that's the exact answer. So if I do 10 pi on my calculator, I get 31.41, and it says 5.9, so I'm going to do 6. And that's in centimeters. So that's like a distance around, so that's just a length. Okay? So notice if you guys use 3.14, what if I did 3.14 times 25? When I do that, I'd get 78.5, and it'd come out nice and even. Right, but there's other decimal places back there. I need to show you the math fails PowerPoint I have. Have I shown you that yet? Yeah, remind me later and I'll show you. I keep meaning to show you that. Why it's important to be precise, because sometimes people make major errors in real life because they're not precise with their measurements. Okay, so number 3. So it says find the area and perimeter of the triangle defined by -2, 3, 0, 7, and 3, 3. So this little triangle. And we want to know its base and its height. So luckily its base and height we can read off of this graph. Okay, so the base is going to be the distance horizontally from A to C. So I'm going from -2. Whoops, did I draw mine in the wrong spot? -2, 3. I think I drew mine in the wrong spot a little bit because it should be at -2. I did it at -1. All those little tiny measurements here. There it is. All right, does that make sense? So I'm going to go over from -2 over to C, which went to 3. So what's the distance along the bottom? If I go from -2 all the way over to 3? 5. Yeah. And what about the height? So that started from a height of 3 and went up to a height of 7. So that's going to be 4. Yep. So our area then is going to be 1/2. Base is 5 and height is 4. So you get half of 20, which is 10. Okay, but then it asks for the perimeter. So we know part of it. We know this side, AC. We know that AC is the distance of 5. But what about AB and BC? So this is the one reason I probably shouldn't have skipped 1.7 yet. I should do them in order. Okay, so who can tell me how to find the length from A to B? Let me help you out here. So A to B has 2 units here and then a 90-degree angle and 4 units here. How could I get the length AB? Brett, what do you think? Exactly. So let's make this C or X, it doesn't matter. And we're going to do the Pythagorean Theorem. So hopefully you guys have all kind of heard that before. So it's 2 squared plus 4 squared equals X squared. So we have 4 plus 16 is 20 equals X squared. So X is the square root of 20. All right, we can simplify that square root. You guys remember way back when we simplified square roots? So 4 goes into it, so it breaks into 2 root 5. All right, now let's look at the other one. So we have B and then C, or B to C. So let's call that Y. And again, we have 3 units on the bottom and we have 4 for the height. Doesn't mean know right away what it's going to be. Have you seen these before? So we're going to do 3 squared plus 4 squared equals Y squared. So you get Y equals 5. Have you guys heard of 3, 4, 5 right triangles? That's a special one. And a lot of times geometry teachers were very lazy. We use it a lot. We're not lazy. Teachers are never lazy. What was that? All right, so AB is 2 root 5, and BC was 5. So our perimeter then is going to be all of those added together. So we're going to have 5 plus 2 root 5 plus 5. So the only way we can combine is just to combine the 5s and say 10 plus 2 root 5. Okay, that would be the exact answer. Okay, do we have units? No. So when we don't have units, for area we write units squared. And for perimeter we just write units. So it shows, oh, if I did have a unit, if I had inches or feet, it would be like square feet, square inches for the area. But not for the other one. Okay, good so far? All right, let's try some harder ones. I think you guys can handle it. You guys are a smart bunch. So number 4, so it says the area of a rectangle is 64 square meters. The length is 4 times the width. So our area is 64 square meters, and our length is 4 times the width. So I want to use some variables in this. Okay, so the best thing to use would be probably W. We want to use variables that make sense. So if the width is W, how do I notate the length? Yeah, Keegan? 4W, totally. So if I talk about an area of a rectangle, I take my length times my width, or base times height, right? So my area is going to be length times width, which in this case is 4W times W. And it equals an area of 64. So 64 equals 4W squared. So we divide by 4 and we get 16. So what's the width? 4. Now, there's actually 2 numbers for W that would make W squared equal 16. I could get 4 or negative 4. So sometimes you'll see me be like, oh, I'm going to take the square root and I'm going to write plus or minus. But why do I not need a plus or minus in this case? Why can't I just say, oh, W's 4? Yeah, it's like a length, right? It's a distance. I don't need negative 4, right? I'm not going to be like, measured negative 4 inches. That's weird. Okay, so we just use 4. So our width then is 4, yeah.
Wouldn't there be like a simpler method of finding W?
I think that's probably the simplest. I mean, you could probably do like guess and check, but that might take a while on other problems. Like what if this didn't come out nicely? What if it was instead of 64, we had like 62? Yeah, that's going to be a little bit harder. So then we would need to take the square root still. All right, so we have 4 meters, and then we're going to multiply, our dimensions then are going to be 4 meters by 16 meters. Okay, so that's what we call dimensions. So some of you guys may not have heard that word before, especially if you're an international student. Have you guys seen the word dimensions? Do you know what that means? So it means like length by width, okay? So when we measure things, like if I'm measuring a piece of wood, I'm always like, oh, it's a 2 by 4. Okay, so what does that mean? What's a 2 by 4? So we write like length by width. Okay, so you're putting in a fence around a rectangular garden with a length of 15 feet and a width of 8. And I don't care which one's your length and your width on the picture. Like, I'm not really picky about which one's which. what's the length of the fence that you'll need? So maybe I should say, what is the perimeter going around? What's the total amount, maybe I should say. Because the length is like 15, right? So what's the total amount of fence that you'll need to go around? So we have 15 plus 8 plus 15 plus 8 is our perimeter. Okay, so 23 plus 23, so 46 feet is how much you need. All right, still feeling pretty good about these? All right, number 6, you have a 9-inch by 12-inch painting. You would like to mat the painting before purchasing a frame. You would like a 3-inch border around the painting. So we're going 3 inches around. Okay, this is a type of question that you're going to get all the time. You're going to see it in Algebra 2 and Pre-Calc. We're going to do these a lot. Okay, so when you talk about a 3-inch border going around, if I want to talk about the distance from here to here, it's no longer 12. 12 is only from here to here. Do you guys see? So how much do I need to add to 12? 6, right? Because I need to add 3 inches below and I need to add 3 inches above. So we have 3 inches here and also here. So when I add 6 to it, I get 18. So same thing for the 9. It's no longer 9, but we added 3 in both directions, 3 and 3. So what do we really have? 15, right? So an 18 by 15. So what size of frame should you purchase? An 18 by 15 inch by 15 inch. Do you guys know those two little tick marks mean inches? Like 5 feet 9 inches, right? So that's the size of frame you should purchase.
Or feet 1.
Yeah, feet is 1. So if I was talking about my height, 5 feet 9 inches, it would look like that. All right, so I could ask lots of questions here. So I might say, what is the area of the frame that you need to purchase? Does this make sense? Like I could ask lots of different things. All right, so number 7. So the Pantheon is a building in Rome, which was originally built for the 7 Roman deities, so the gods of the 7 planets. The building has a large dome that is 43.3 meters in diameter. What is the circumference of the covered floor? What is its area? Has anybody ever been in this building? Yeah, it's kind of cool, isn't it? So from the outside, they made it look like it's like a rectangle. So if you're standing directly in front of it, you don't know that it's circular on the inside. And then you walk inside the building, and the floor is actually like a little bit rounded too. And they had that for a couple different reasons, but one of the reasons was for drainage. So the water would kind of go to the middle if there was water in the building. But it also kind of makes the eye think that you're in a sphere, like the planets, right? So I don't know if they knew that the planets were round. I'm sure they did. I don't know. They didn't know the Earth was round, but they knew that those were. They thought the Earth was flat, but yeah, but they could clearly see the planets were right, or in the distance. I don't know. So anyway, so what is the circumference of the covered floor? What is the area? So we have this big circle. So when you look up, can you guys see in the picture? You got this big like dome above you. And the floor is a big circle. And so it's 4.3 meters across, or 43.3 meters, sorry. That would be tiny. 4.3 meters, woo. How exciting. So 43.3 meters. So what is the circumference of the covered floor? So our circumference then is going to be our pi times diameter. So we just have 43.3 times pi. So let's find it rounded to 3 decimals. I always do 3 decimals because that's what you need to do in your upper level classes. So if I don't say, do 3 decimals. So 136.03, it says 0309619. So I'm going to do 031. And that's in meters. So what is the area? So it's pi times radius squared. Well, in order to find the radius, I take my 43.3 and I divide it by 2. So I get 21.65. So I'm going to take my pi and I'm going to multiply by 21.65 squared. So I'm first going to do the 21.65, and I'm going to square it, and then I'm going to multiply by pi. So it's 1,472.535 square meters. Okay. Makes sense? All right, so 8A. So it says find the areas of the irregular shapes. So I did leave off one marking on C. I want you to mark this congruence mark and this congruence mark. I meant to put that in before I printed it and I forgot. I keep trying to put it in on Word, but it's never going in the right spot. It makes me mad. Okay, so for part A, do you guys know how to do these? What do you guys think we should do?
Just divide.
Yeah, what do you think?
Kind of like get them to equal out on both sides, on all even sides.
Yeah, so you can kind of like,
Add 'em up.
yeah, maybe like divide it somehow. I don't know. Is that what you're saying? So you could divide it there and there. Maybe you could divide like this way. It doesn't matter how you divide it up, but we need to figure out what all these areas are. Or you could even do the big rectangle, right? And then subtract out the little one. You could do that as well. So however you want to do it. So let's see. So let's say I divide it in the first way that I did, so horizontally. Then I have 3, 6. This is probably 3 then, right? Because it's a rectangle. I had 11 originally, 3 down here. So what is the distance from here to here that I'm drawing in red? So from here to here now.
9.
Nope. So instead of 11, 11 was the whole
Oh,
distance
5.
from here to here. Yeah, so it's going to be 5, right? Okay. So it looks like maybe we have, okay, so we have 3 centimeters going across here. So what is this?
3.
3, yeah. So let's do rectangle number 1 up here on the top. It's going to be 3 times 6, right? Uh-huh. So I'm going to do 3 times 6 plus rectangle in the middle,
5 times
3 times 5, so 15. Plus last rectangle,
18.
3 times 6 again. So we have 18 plus 15 plus 18. So what do we get? 36 plus 15, 51. So it's 51, and since it's an area, we're going to write centimeters squared. Would you be able to find the perimeter? Sure, you just add up all the sides going all the way around, right? Okay, so the next one. So we have a rectangle. So sometimes I like to piece it out. I like to be like, oh, the area of the rectangle and the area of the semicircle. So I draw like little subscripts. Like A, subscript rectangle, A, little semicircle. Semicircle's struggling. Make it a little prettier for you. Okay, so how about the area of the rectangle? So that's going to be,
10 times 4.
which is 140, right? So we got that. Done. All right, so what's the area of the semicircle? Well, it's half of the area of a circle, right? So I'd say half of the pi r squared. So it's half of pi times, our radius is 7, right? 7 squared. So it's the lovely 49 pi divided by 2. So 49 over 2 pi. You guys see how we did that? So I did my 7 squared and got 49. I multiplied by pi and had 49 pi over 2. So I can put the pi on the side or I can put the pi on the top. Doesn't matter. So if I want to talk about this total area, it's 140 plus 49 over 2 pi, or 49 pi over 2 if you want. Okay, so that would be an exact area. I can't combine that anymore because one of them has a pi, one of them doesn't. But if I wanted to find a decimal approximation, I could. I would just put that all into my calculator as it is, and I'd say, oh, it's 216.969 millimeters squared. All right, and then the very last one, where do you guys think that we're going to cut this one? What 2 shapes do we have? What 2 big shapes do we have? Yeah?
Yeah, triangle.
Yeah, triangle and rectangle. So here's our triangle. And so it said that we had 8 centimeters. This 8 is for this distance right here. Okay, so if this is 4, then that means the height of this triangle is 4, right? So we need to figure out the base of the triangle.
So subtract 6 from 12.
Yeah, we subtract 6 from 12 because we have 12 going all the way across, and we're subtracting out 3 and 3, right? So the blue line that I drew in is 6. 12 minus 6, right? It gets a little hard to see all your drawings after a while. So we could break it apart and we could be like, oh, the area of the triangle and the area of the rectangle. So we can put it together. So the area of the triangle is 1/2 base, which is 6, times height, which is 4. And our area of a rectangle is 4 times 12. So we get, what, 24 divided by 2, so 12 plus 48. So we get 60 centimeters squared, and that's our answer. Okay. Do we feel pretty good with the area? Okay, good. So looking around the room, tell me what I would measure in like centimeters, millimeters, feet. We'll talk about that.